Good morning. We're going to start lesson 6.2 today, which is talking about series. And so you're going to see a lot of new notation in here. I'm going to walk you through everything, and I don't want you to panic. But basically what we're going to be doing is taking a pattern and adding up a certain number of the terms, okay? Which might not seem like real complicated. So if I just gave you a pattern like 1, 2, 3, 4, 5, and I said add up the first 3 terms, not a problem. But the issue would be, what if I told you the pattern was 1, 2, 3, 4, 5, and I wanted you to add up the first 1,000 terms? Then you're running into some issues. So what we're going to be doing is we're going to be using some formulas to help us do these more complicated tasks. And in order to do that, we need to introduce some new notation. So let me get this out of here. And we're going to start with summation notation. So that's what this little symbol is here. It says summation notation is the sum of the terms of the sequence denoted as, and this would be your summation notation. And the way that this works is this big E symbol, it's called sigma, that represents an arithmetic operation. And so what this sigma means is it means to take a certain number of items and add them together. Okay, so that big sigma symbol means add all the things, okay? Now down here, the summation doesn't work unless you give it commands. So down here, it's telling you where to begin in your list of numbers and where to end. So this is like the start value, and this is like the stop value. Now we're going to be referring to pattern or numbers in a pattern. So down here, this k equals 1 means that put 1 in place of k, meaning A1, or the first term, would be where you start, and then put n at the in place of k, and that would be where you stop the terms. So this would mean take the terms in a pattern, first term plus second term plus third term plus fourth term, all the way up until you get to the nth term. And I should have actually put a plus sign here. And so usually what we'll see is we'll see n is going to be a number, like maybe 10 or something. So if there was a 10 up here, that would mean stop at the 10th term. So this is telling you where to begin in a pattern and where to stop in a pattern. All these formulas down, or all these definitions down here, they should all look somewhat familiar. You're seeing geometric and arithmetic again, but now the term is series and not sequence. And so the difference there is that a sequence is a list of numbers, where a series is the sum of all the terms in that sequence. So a series, the word series means sum, okay? So we have geometric series, that just means that you have a multiplication pattern and you want to add up all the terms. An arithmetic series means you have an addition pattern and you want to add up all of its terms, all right? An infinite series would just be if you have a series that continues on forever and we want to add up all of its terms, which is kind of an interesting concept that we'll touch on more later. A finite series is a sequence where you want to add up all the terms to a certain point. So that would be like what I said up here. If you want to stop at the 10th term, that would be considered finite because it has a clear ending point. And then the last definition is a partial sum. That just means that you're going to add up some of the terms in a sequence, but not all the way to infinity. Okay, so before we can begin, we do have some formulas that we're going to need to help us find these sums for an arithmetic series. Remember, that just means take all the terms in a pattern and add them up. So here's the formula. So the first thing that you should note in the formula is that A1, we've seen that symbol before, that just means your first term. A sub n would be the last term. So that could vary. That could be literally the last term in this series, or it could be defined for you. Like if you want to add up the first 10 terms, then that a sub n value would be what's the value of the 10th term. Okay, n would be the number of terms that you're adding up in your series. Okay, so we're going to take the number of terms divided by 2 and then add a1 plus an. So let's look at an example. I'll come back to these other formulas here shortly, but we have an example first of an arithmetic series. So it says a corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? So for you visual people out there, basically this is like in a theater or stadium, sorry, and there are 8 seats in the front and then be 10 seats behind it and then 12 seats behind it and so forth, okay? So how many seats are in the entire section? So basically we are being asked to add 8 plus 10 plus 12 plus, continue this all the way until we get to the top row, which has 24 seats. That's what we're being asked to add. Now, it would be really easy for us to just go to a calculator and type in all that stuff. That's fine. But we're going to practice using the formula just so we get a feel for how that works, and then kind of consider the fact that this is a simple example, but other examples might not be so simple, like 8, 10, 12, all the way up to 24. That's not that many numbers for us to sit and type out, but if this ended at like 24,000, that's a lot. So we're looking for more of a procedure to make things easier when the problems become more difficult. And so what we're going to do is we're going to recognize that this is asking us to add terms, which is the equivalent of finding a series. And that in this case would be an arithmetic series. And it's arithmetic because the pattern is adding 2 each time. Okay, so you're going to go back to your formula on the last page. Hopefully you've got it written down on your paper, but I'm just going to write down the formula as is. And then we're going to plug everything into it. Okay, so in order to find the sum of however many terms, we need to plug in n, we need to plug in a1, and we need to plug in an. And actually, I'm going to slide this over so I've got a little bit of room to work. Okay, a few of these things we do know based on the information given in the problem. We do know the first term is 8 because there's 8 seats in the first row. And we do know that the last term is 24 because we know there's 24 seats in the back row. What we don't know is we don't know how many rows there are. Okay, we don't know how many rows there are. And n would represent the number of terms in your pattern. And the number of terms, like 8, 10, 12, represents how many seats are in the first row, second row, third row. So I need to know like how many rows there are in order to find the n value. So I'm going to have to put this formula for finding the series on pause, and I need to go over and figure out what n would be. And so the way that I'm going to do that is I'm going to use an explicit formula from the last section in the notes. And I'm going to use this to find the value of n. Okay, and so the way I'm going to use my formula is I'm going to start with what I know. An can be any term in the pattern, but I'm just going to use 24 because that's what I'm trying to find the n value for. So I'm going to say 24 is the last value in the pattern. A1 is 8. D would be 2 because the pattern's adding 2. And you're going to find the value of n, and this is going to be done just with simple Algebra 1 skills. So I'm going to distribute You could either combine like terms or just go ahead and subtract. So I'm going to flip some things around. I need to subtract 8, and I also need to, well, actually 8 minus 2 would be 6, so I'm just going to subtract 6, right? And so that would give me, sorry, checking my math. That would give me 18, and then divide by 2, and you would get 9. So that means that this is your first term, this is your second term, this is your third term, obviously. But that means 24 would be your 9th term. So that means there are 9 rows in this stadium. So if n is equal to 9, now I can go back and I could plug 9 in for n. I can also say that instead of S sub n, which S means sum, n means number of terms, I'm going to say S sub 9. So this means the sum of the first 9 terms. So the sum of the first 9 terms. And I'm going to just go through and do the math now. So 9 over 2, I'm going to leave it for the moment. 8 plus 24 is 32. And then I need to do 9 over 2 times 32. For me, I don't have a calculator in front of me, so I'm going to do this. I'm going to say 2 and 32 can both divide by 2, and that would give you 16. So I really just need to do 9 times 16, which would be 144. So there are 144 seats in this auditorium. Okay, so now we need to go back and we need to look at that formula for geometric series because we're about to do a problem with that. Okay, so there's 2 formulas actually for a geometric series. These are both for a geometric series, but one is for a finite series and one is for an infinite series. Okay, a finite series means that you have a clear ending point. So you could say add up the first, I don't know, 7 terms. That's a clear ending point. An infinite series is one that goes on forever, which we'll talk about that here soon. So here's our formula. Let's just break it down. Remember, S means sum, N means the sum of however many terms. A1, we know, that means first term. R, we've seen before in the last section. R represents the common ratio, like what you're multiplying or dividing by in your pattern. And then N is going to be the same as it was up here for an arithmetic series. This is the number of terms. Okay, I mean, just don't overthink it. It is a formula. You're just plugging stuff into it. So in this case, I need to find the first term, I need to find the common ratio, and I need to find the number of terms in order for me to be able to find the sum. Okay, so find the sum of the geometric sequence 4, -4/3, 4/9, -4/27, and so on. And then this we'll kind of break down here in a moment, but let's just plug in what we know. So do I know the first term? Yes, the first term is 4. Do I know the common ratio, which is what am I multiplying by each time to get from term to term? It looks like you are multiplying by -1/3. Just a quick review, if you aren't sure how to do that, remember you can just take a term and divide by the one before it. So I could take 4/9 and divide by the term before it. And I'm going to simplify by doing outer inner, which would give me what, 12, well, -12 over 36, and that reduces to -1/3. So that would be how you could find the common ratio if you forgot how to do that from the last lesson. Get this out of the way. Okay, maybe not. Okay, so we're going to figure out what the sum would be. So in order to do that, I needed to know 3 things. I needed A1, I needed R, but I also needed N. N is number of terms, okay? So let's kind of talk about what this means. This is going to give us that information. This here